Hello everybody. So today we have already done inverse kinematic methods, and within that we have seen what is kinematic decoupling, and we have already discussed why we do decoupling. Decoupling is basically done so that a big problem is reduced into small subparts. Now if you remember, the steps of kinematic decoupling basically dealt with trying to take a 6 degree of freedom robot manipulator, its transformation matrix, and basically divide it into two parts, subparts. One was 0R3, 0, 0D3, 1. And another part was 001, and this was 3R6. Once we divide like this, we said that the good thing is that from this one we will get Q1, Q2, Q3, and from this one we will get the remaining Q4, Q5, Q6. Now if I am going to take any robot manipulator for that matter, I can draw it very simply as this. So suppose if I am having you know a joint like this, I'm not going to say which is this one because I'm just giving it as an example. So these are the first three: hip, shoulder, elbow, and then finally we have the wrist. The wrist is itself comprised of three joints. Finally we have the end effector. So this is the 0th frame, this is the end effector. So totally we will have, starting from 0, this will be the 6th frame. And when we say 0 to 6, what we are trying to say is we are trying to find out what is the end effector frame related to the base frame. Now when we say something like this, we can write it as 0T3 and 3T6. It's the multiplication of these two. So the first three, 0T1, 1T2 and 2T3, these are the three which we multiply, which is basically A1, A2, A3. If you remember, that was from DH convention. So from the DH, we are able to find out A1, A2, A3, and that is what we multiply to get this one. The wrist part, we said that again we will have A4, A5, A6, with which we will get what is called as the wrist. So this is the wrist part, and this is the arm part. This is the arm part. So the first three joints form the the arm, and the last three form the wrist. So this is the arm part and this is the wrist. Now generally if an inverse kinematic problem is asked, we will expect what? We will expect that they will give some 0T6 and they will say that find out Q1, Q2, Q3, Q4, Q5, Q6. The 6 joint variables when you are given this. That is what generally inverse kinematic problem is asked. Or they may say that there is a robot and the robot is basically comprised of a, let's say, articulated arm, or let's say spherical arm, anything. So let me say articulated arm plus a spherical wrist. And then they will say find out Q1, Q2, Q3, all the way up to Q6. So they are not giving 0T6, they are directly giving you the robot, that it is an articulated robot fitted with a spherical wrist. Already we have done in forward kinematics what will be the link parameter table for an articulated arm and what will be the link parameter for the spherical wrist. And based on that, we can basically make the link parameter table. We know it is comprised of theta 1 d1 theta I di ai, and finally alpha I, and this is I. And based on the 6, so articulated will have first three joints, and the spherical wrist will have the next three joints. So based on this, we will get what is A1, A2, A3, and using these three we can form what is called as 0T3, multiplication of A1, A2, A3, and the next one A4, A5, A6 together we will get 3T6. So even if they give that problem, we will be able to find out what are these two, and based on these two we will be able to get what is 0R3, 0D3 and 3R6 based on the DH convention. So the problem, what is the range of the problem? Already we have studied that in robot we will have robotic arm of 5 types. Which are they? They are basically cylindrical, Cartesian, spherical, articulated, and finally SCARA. These are the 5 models. And in wrist, which all are there? In wrist, generally we have 2 kinds of wrist. One is called as a spherical wrist, and the second wrist is based on Euler. Now we have studied both, but if you take your syllabus of KTU, in your syllabus it is written spherical wrist attached to various robotic arm. So generally the range of the problem that we will have is either a cylindrical one attached with a spherical wrist, or a Cartesian one attached with a spherical wrist, or a spherical arm attached with a spherical wrist, or an articulated one, or a SCARA arm attached with a spherical wrist. So these are the range. This is the range. Beyond this there is nothing to ask. Otherwise they should ask a totally new robot, which seems very, very less, because the time required for doing the inverse kinematics is huge. So if that is the case, then what we can do is we can now solve the inverse kinematics of these separately. So we will try to solve the inverse kinematics of cylindrical separately, Cartesian separately, spherical separately, articulated separately, SCARA separately, and even spherical wrist separately. Once we have got the inverse kinematics, that means if we are given a cylindrical, how to find out Q1, Q2, Q3, if we are able to do for cylindrical, for Cartesian, for spherical, for articulated, for SCARA, for each different cases if we do. And similarly, if we are given a spherical wrist, then how to find out Q4, Q5, Q6. If that we are able to do separately, then whatever be the problem, we will be able to find out the answer for that, because we have done the 2 parts separately. So next set of problems, not problems, the next set of numerical analysis that we are going to do is to find out Q1, Q2, Q3 for the cylindrical robot, for the Cartesian, for the spherical. Now I'm not going to do each and every one with the same intensity that I have done in the forward kinematics, because that's already available for you to see. Because already we have done for cylindrical, what is the link parameter table, or for Cartesian, what is the link parameter table. Like that for each and every one we have done. Similarly we have done for spherical. So what I will do is I will directly borrow from there, and I will then try to find out Q1, Q2, Q3 for the case of the arms, and I will try to find out Q4, Q5, Q6 for the case of the spherical wrist. And then what we will do is we will look at a problem which is a combination of both of this, and then it will be easy for us to do. So without wasting time, we will directly jump into the problem. Thank you.